Welcome to the 13th edition of the Times Techies webinar. I have my colleague Sujit John as my co-host for today's webinar. Today we have with us Dr. Viral B Shah, one of the creators of Julia language and co-founder and CEO of Julia Computing. Welcome, Viral. Viral will speak to us about big data, analytics, and the Julia programming language. Julia combines the use of Python with the speed of C. It has been downloaded over 10 million times and is now taught at MIT, Stanford, and many universities worldwide. The Julia co-creators were awarded the prestigious James H. Wilkinson Prize for Numerical Software. Apart from Julia, he's also one of the authors of Circuit Space, an open source program which borrows algorithms from electronic circuit theory for ecological conservation. In the Government of India, he was an early member of Aadhaar, where his work on re-architecting India's social security system led to a significant increase in social and financial inclusion. His book, Rebooting India, describes this experience and what it takes to execute large, bold projects in the government. Viral has a PhD in computer science from the University of California, Santa Barbara. More recently, Viral and team organized JuliaCon, the conference dedicated to the Julia programming language. It was held virtually this year on July 29th through 31st. Welcome, Viral, to the Times Techies webinar, and over to you.
Thank you, Shilpa. Great to be here, and great to see everyone. I'm sure that everyone is watching this from home, just like I'm streaming from my home right now. And I wanted to use this opportunity to connect with our audience about open source software around the Julia language, around what's happening next in AI, especially with the field of differentiable programming. And just generally talk a little bit about, about careers and various sorts of, topics related to open source software and AI. I had a quick question, Shilpa. Is if there are questions from the audience, will you be able to moderate and sort of interrupt me and ask me?
Yes, Viral. Sujit and I will do that. We'll take in questions from the chat box.
Okay, perfect. So I always prefer sort of people to interrupt me while I'm speaking so that we can make it a little bit more of a conversation. It's harder to do it when it's online, but let's try to do that. So I'll just start talking, but please feel free to interrupt me and ask questions.
Sure.
So, this is, I have a few slides, but these slides are largely sort of a storytelling aid for me. A lot of people ask me, why create a programming language, right? Why create Julia? And I always, have a, it's always not a straight answer, right? It's a complex story, but if you look at sort of the last 25 years, there have been languages like Python, R, SAS, MATLAB, in which you write your algorithms. Like if you're a data scientist, if you're an AI person, if you're a real scientist, pardon me for saying that, or an engineer, then you're using these languages like MATLAB or Python, or if you're a statistician, you're using R and SAS to prototype your algorithms, your languages, to draw insights from your data. But then when the insights that you draw and the algorithm you perfect has to be run on data at large scale, it has to be sort of, put into production, as we call it, right? Then these languages are not sufficient, and people end up often rewriting the algorithms in C++, C#, Java, your typical systems languages. And you can already see the tension here, right? That these are two different worlds. That the worlds of Python, R, SAS, MATLAB are what are used by the domain experts, because they don't want to sort of be bogged down by the details of C++ and Java, right? The C++ and Java programs tend to be like often up to 10 times larger in size, and they're very messy to work with. And the amount of code you have to write comes in the way of your understanding of the algorithms themselves. What ends up happening is that you end up writing all the programs twice, right? And coming to think about it, that does not sound like a good idea. Why can't we just write our algorithms in the same language and then deploy it, into production, just in one shot, right? Not only that, it's, the difference between the deployment languages and the production languages have, they're used by different sets of people, right? So not only is the two language problem a technical problem, but it's also a social problem. It puts the innovators or the people who are sort of coming up with the ideas and the algorithms onto a separate platform from the people who are putting those ideas into production. And what Julia lets you do is bring the computer scientists, the programmers, the data scientists, everyone using the same language on the same platform. And that leads to a lot more collaboration. For example, if you come to the Julia Discourse website, right, the Discourse mailing list, you will see all these people talking together, right? If you go to the R mailing list, you won't have production people, for example. Or if you go to the MATLAB mailing list, you won't have people talking about, hey, how do I run this program in a production system? But if you come to the Julia mailing list, you'll have people who are, talking about all these things together. So it's as much of a social construct as it is a technical construct.
So how does the difference come about, Viral?
That's a very great question. So what makes it possible for Julia to do this, right? And it's what Shilpa said in her introduction, right? That Julia has the speed of C, but the ease of use of Python. Now, where does the speed come from, right? And people often ask me this question, like, is there a magic thing? For example, can I take that magic technology and just put it into Python because I really don't want to learn this new thing? And if I could just put it into Python, then maybe Python will be fast, and whatever I have learned in Python, or, can I just put it into R, or can I put it into Excel, right? I mean, even better, like, then I don't need to even program. And so I usually give sort of a little bit of a funny answer. And what I usually say is that, what makes a Ferrari a fast car, right? Why can't I just go and take my, can I take my Tata Indica, right? And then bolt on a new engine and change the fuel I put into it. And then can I put some, customizations on it? And then will it just go fast, right? Like, can I just throw out all the seats and all the unnecessary weight inside? And will that Tata Indica now become a Ferrari? The answer is no, right? You can do a few things. You can speed it up, you can soup it up a little bit, but it cannot become a Ferrari because the Ferrari was designed from the get-go to be a fast car. So every decision the designs of a Ferrari made were with performance in mind. And the same applies to programming language design. When Julia was designed, every design decision from day one that we made was keeping in mind that, this is what will make the language fast. And if it did not help performance, we did not put that feature into the language, right? And that is what makes Julia fast. So you really have to start from the drawing board in order to achieve your goal. You cannot sort of retroactively fit it onto an existing system. Now, that does not mean it's impossible, right? Like JavaScript, for example, is a phenomenal example of a system that was not a language that did not start out as high performance, but was eventually made very fast, and that's what powers the web. But it's unlikely that we'll see that, for example, with Python or R, which are fundamentally very different kinds of designs. So I hope that maybe answers that question of why.
That Julia is used in production as well? Yes,
absolutely. In
all fact, the time?
Sorry?
All the time? Is that how people prefer? Or is it that, the many instances where people also may use Java or C when they go into production?
I would say that Java and C are obviously the dominant production languages right now, right? Julia has only been on the scene for 10 years now. And in programming language years, that's like it's a baby, right? But the people who start out with Julia, right? So people who so think of engineers, think of your biologists, think of data scientists, people who are writing the new AI algorithms. These people are already using Julia in production because they don't need to rewrite their codes. And so people who are already in the Julia world use it in production. But of course, there's 25 users of C++ users out there, or C users out there, who are not going to be able to move to Julia into production. So it's not that if you're using Java for production, you should move to Julia. It's that when you have, when you're doing deeply domain specific code, right? If you're working with algorithms, right? If you're trying to discover a new drug, if you're trying to predict the climate, if you're trying to, predict the weather more than the climate, climate you can only simulate. if you are, for example, if you're building a new search engine, right, which is heavily mathematical, that's where you would sort of start out with Julia. But if you're building, a mobile application, I don't think Julia is the answer to that, right? So it's not the one thing that solves everything. It's specifically for very large data sets where you're building very complex algorithmic, new applications where it actually makes sense. If you're doing, for example, a lot of signal processing, right? Let's say you have a lot of sensors, you have data coming in, and you're processing it all, and you are doing something. So think of a system like Aadhaar, for example, right? And all the gigantic computation it has to do. That would have been a fantastic system to write in Julia and deploy into Julia, for example.
It wasn't. Is it? You are involved in Aadhaar, no?
I did work in Aadhaar. I don't think there is any Julia used in Aadhaar because Aadhaar was being developed at the same time as Julia. I in fact started both on the same day. Yeah, I started working in Aadhaar and the Julia project both when I had moved to Bangalore, and literally the same time. So the core of Aadhaar is this massive deduplication system, right? And it is doing signal processing. I mean, it's getting images of your fingerprints, it's getting images of your retinas, it's getting your photo, and then it is matching them with all the other biometrics in the database to see if you already have an Aadhaar or you're a new person who's been given a new Aadhaar. And that can only be done, and that is one of the world's largest parallel computing programs that is used in the field of governance.
Sure.
So in the past, e-governance was all about filing your taxes, right? I don't know what was, it was all about form filling at some level, right? But with Aadhaar, it became a scientific computing problem. And that would have been a fantastic algorithm to write in Julia. So if you were to start today, that's what you would do.
What was it eventually written on? Java, is it?
Well, it's just like any other government system, it's a like large parts of it are procured and large parts of it are vendor written, right? So it is a mix of all kinds of things. So there'll be pre-existing technology that was probably written in C and C++, and then there'll be bits in Java, and there might even be bits in other things that we don't even know what's under the hood. So it's a system integration plus a new development, right? It's all kinds of things. I mean. And then it had a client-facing side. So it's just a completely, complete mix of all kinds of things. Sorry, go ahead.
Go on.
So, I think the Aadhaar discussion, especially around, matching images, biometrics, faces, retinas, that brings me to the topic of AI, right? So the field of AI has revolutionized this field of image processing. And, I like to show this slide, right, about who is going to own the AI platform going forward. And today we think of AI as, okay, can it match a face, or can it detect an image? Like, okay, this image is that of a cat or of a car. But Jan LeCun, who recently won the Turing Award for his work on deep learning, actually said that deep learning is dead and long live differentiable programming, that we need to be able to bring these capabilities not just into image processing and speech processing and language processing, which have been the fields that have been solved, but also into every aspect of problem solving, right? Every aspect of scientific, this is my addition to what Jan said and my interpretation, but we need sort of the entire fields of scientific discovery to incorporate differentiable programming in them. We need the entire field of business programming to incorporate differentiable programming in them. I mean, why can't an AI system, for example, optimize all the tax returns that have ever been filed and come up with a simpler tax system for the whole country instead of filing this complex sets of rules, right? Why can't we use AI for, in our meteorological system and come up with better predictions of weather? And why can't we come up with better climate policies? Or why can't we come up with better drugs? Would there be a faster way to get a vaccine for the ongoing pandemic? And the real world is very messy and complex, but AI algorithms have shown us immense promise in terms of being able to process large amounts of data and using large amounts of compute to solve real problems. And in order for the AI technology to be widely applicable to all these different kinds of problems, what we need is a technique called differentiable programming. And I think for our audience, I'd like to maybe give you a quick explanation of that. So you might remember from your high school, from your 10th standard days or 11th standard, if you took the science stream, that there was this concept of taking a derivative, right? That and if you remember some of these rules, it's like, oh, the derivative of sine is cosine, for example, and the derivative of logarithm is 1 over x, right? Log x. And there are all these rules, and then there was sort of this chain rule. If some of you recollect a little bit more about your derivatives, that how do you apply it to a large system of equations? And differentiable programming is exactly that. Now, why does this matter? If you remember, derivatives, are all about sort of the rate of change of something, right? So, if I have speed, if I'm at a position and I take a derivative of my position with respect to time, I get my speed or velocity. And if I take a derivative of my velocity, I get acceleration, right? And so these differences, so for example, what happens in my body when I ingest a drug, right? The drug is being ingested through my digestive system, and the rate at which it is being consumed by my body will define how it acts upon my body, and then how my body will break it down and eject it eventually, right? Finally, the mass has to be conserved, even when you eat a drug, right? If otherwise, you'll keep eating drugs and then it's accumulating in your body. They have to be broken down and ejected after they've done their job. But it is these rates of changes that matter a lot for everything, right? So if I'm designing a car, what is the rate at which the fuel is being injected into the system and being combusted and burnt and so on and so forth, right? So derivatives are everywhere. And what derivatives let us do is they let us optimize the design and come up with the best answer. So that was the deep insight in the AI systems, that if we are able to take derivatives of large complex systems, then we can optimize over them, and then we can teach systems. So for example, if I show a computer a picture of a cat and it thinks it's a dog, then I can look at the difference between the two answers, and then sort of teach it how to go in the direction of the right answer instead of the wrong answer. And then I keep showing it millions of these images. So these derivatives, this ability to take derivatives is what is teaching the computer, is what is creating the learning in our systems today. So then the answer is, if I can take derivatives of all kinds of software, then maybe I can bring AI into many more domains than was possible before. And that is the fundamental insight in differentiable programming. And that is what Julia is enabling. It's enabling the ability to do differentiable programming on a broad variety of systems, compared to what AI algorithms have been today. And this is what Andrei Karpathy, who's the director of AI at Tesla, called software 2.0, that instead of writing your program in the traditional way, like writing code, we may be able to now sort of use this new paradigm to in fact use computers themselves to write code in a very broad and hand-waving sense. And this is sort of, so the question then naturally occurs, that what is the language of, this new paradigm of software 2.0? And if you remember my analogy of the Ferrari, right? If something was not designed from the get-go for a purpose that it's trying to address, you cannot, it's going to be a sort of not a great fit. And so it turns out that while Python has been sort of the dominant language in AI, largely for users, it's not a great language for writing AI systems, because under the hood, it's the two-language problem. It's, the users are using Python, everything under the hood is written in C++. But if we can write everything in a differentiable programming language, whether it is Julia, whether it is Swift, or whether it is something else, that is what will unlock these possibilities. Of course, from a business perspective, from a careers perspective, these are new technologies that are coming up, and people who master them will be in high demand. Companies that master them will take new products to market. I mean, I can imagine, for example, this is the kind of thing that will completely redefine even, entire industries like entertainment, or, I could possibly imagine, like, I could make a complete animated movie, or even a realistic looking movie without actors, right? Or without script writers. I mean, it's, I'm sort of projecting way out, but sort of just trying to help people sort of build that imagination.
Because it's able to figure out what works and all that, is it?
It's the learning, right? That the moment you have this concept of learning built in, you can now have the computer start out with something and then apply what it has learned to create new things. And so for example, you've seen the deep fakes, right? As a very like terrible example, right? And it's a terrible name, but you can imagine the concept of deep fake, right? It was, you didn't record that actor saying those things. We've also seen these things like GPT-3, right? Where the computer is generating fairly meaningful sounding sort of text passages, right? Is it too difficult to combine what GPT-3 does in terms of creating a few paragraphs of text and putting it on an actor's head and what we call deep fake, and creating completely new kinds of content, right? So for example, right, if I have video coming in about a live stream, right, maybe like this one, can I not have a computer look at it, come up with a summary of it, and then put it, let's say Shilpa is the person who's reading it out. Can I not have Shilpa read out a summary of this without her actually doing this? I mean, we can do this today by just streaming together these things, right? So that's kind of what I'm referring to, right? That these things will keep evolving and replacing industries in ways that we cannot even predict.
Okay. I know you're not finished with your presentation, but there's already a question from viewer Radhika saying, how important is the knowledge of mathematical concepts of differentiation and integration to use Julia?
Julia itself is a programming language. So if you know any other programming language, or even if you don't know one, you'll be able to learn it. You don't need to understand mathematics, differentiation, or integration to use Julia. But let me also say that mathematics will make you a better programmer. So go brush up those skills again, if you've not done that in the longest time. But what makes Julia especially interesting for the people who use it is its powerful connection to mathematics. I mean, I often call Julia as the language of science, because of the ease with which you can extract the mathematics, with which you can compute using mathematics in Julia is far superior to anything that has existed before it. It's a great language for doing anything scientific or mathematical. But in order to learn Julia, in order to solve all these kinds of problems I'm talking about, you do not necessarily need to master, you don't need to know differentiation to write a Julia program, for example.
Got it.
Okay, I'm just moving along, yeah. But if there are any other questions, please let me know.
Yeah.
So it was recognizing all these things that, when we were talking about running Julia on Google's tensor processing units, we did a little project of porting Julia to Google's TPUs, and Jeff Dean got really excited. Everyone must have heard about Jeff Dean. He's the head of AI at Google. And, he tweeted out that the combination of Julia, which is the best language, and Google's hardware, which was the, called tensor processing units, that is the best combination for fast and easily expressible machine learning computations.
So what's a TPU?
So TPU is a tensor processing unit. It's a special piece of hardware that Google designed in order to. So when you talk on your Android phone, and when you say, "Hey Google," and you ask it a question, right? Like, what is the weather today? What Google is going to do is send your recording. Well, it got activated right there. It's answering me the weather. No, don't answer right now. Get some more AI into you. Okay. So what it's doing is it's taking some features out of your voice, and then it is sending them back to Google, and then Google runs an algorithm on it, a speech analysis algorithm on it, to try and figure out what you said, and then it sends that query to Google, and then it gives you the answer, and then it reads it out back to you, right? The TPU is what is powering that speech processing.
Really? Okay.
So the TPU is unlike your Intel chip in your laptop, right? It's a very special chip that does only mathematical computations really fast. Okay. Some of you may have heard of GPUs, right? Graphics processing unit, GPUs like NVIDIA's that people use for gaming.
Yeah.
So TPU, think of it very similar to a gaming chip, in the sense that the underlying mathematics is very similar, but it has been special built for this purpose.
Who's built it? Google itself?
Google designed its own TPU.
Oh, okay.
Yes. So GPUs is a graphics processing unit. TPU is a tensor processing unit. The tensor is a mathematical construct. It's an n-dimensional array. It's, at the end of the day, it's just numbers written in a cube, right? So for example, but in deep learning, we work with all these sorts of mathematical constructs, and tensors are sort of common to all of them. And so Google named its hardware the tensor processing unit. But it's really just a custom chip built for doing mathematics really, really fast.
Okay.
So you would be surprised that, a lot of people think that, oh, do I need to sort of get a PhD in mathematics before I can even understand all this stuff? The answer is that, if you remember even your 12th standard mathematics, right? If you remember your, for example, many of you might think about your solving of simultaneous equations, right? That, 3x plus 4y equals 7 and x minus y equals 2. And then, I will eliminate y and then I will substitute it and then calculate x, right? That is all the computer is doing. It's, or if you remember, like simple matrix multiplies, this is all the math that is actually happening under the hood. But understanding it, to your bones and really mastering it is the key to be able to then sort of do this. And then the computer is basically doing this billions of times a second. I mean, that's the name of this game. And Julia does it much better than anything else that came before it. So this was sort of the kinds of things Julia was designed to do.
So Google uses a lot of Julia?
Google uses a lot of Julia. Not in so Julia is not an official language at Google, so it is a research language at Google. So Google has production languages and research languages. So even though Julia itself is a beautiful language to put into production, Google has very strict rules about languages that it puts into production, and they don't take that decision very lightly. So I would imagine it is a matter of time, but a lot of Julia contributors are actually working at Google, open source contributors, and a lot of the research happens at Google. Actually, Google is a very complex company, but so Google has many internal deployments that use Julia, but not in the core Google engine. So there are different rules there yet. But there is just no chance it's not going to happen. I mean, it's going to happen soon. But yes, Google is deployed on thousands of, this is what my friends tell me. I have no deep insight, but that it is designed on large systems within Google. But and it's increasingly making its way towards the core algorithms as well.
Yeah. Okay.
Yeah. So that's. I should.
We have a question.
Yeah.
If I may just interrupt you, it's from Lakshmanan Natraj. One problem with Julia and AI is most of the R&D libraries, packages in AI comes out of Python these days. Any insights on how Julia can play catch up?
Yeah, that's always a good question, right? That when you have something new, people are always sort of looking at the existing thing and then how do you migrate to the new thing? So one answer is, which is an easy answer, is that Julia has amazing interoperability with Python. So it can call anything that is written in Python. But let me sort of peel the onion a little bit for you, right? So the libraries themselves are not written in Python often, right? They're written in C++ and they have a Python wrapper to make them easy to use. Those same wrappers can be easily accessed from Julia. But now the question is, why are they written in C++? Because they're trying to make them available in Python. Python is so slow that you can't even write these things. Well, guess what? If you had written it in Julia to begin with, you would not have these layers of onions of, of the C++ inside and then the Python outside. What happens in Julia is that you can, run it on the TPU or on the GPU and get maximum speed without being a C++ low-level programming expert, right? With your knowledge of Python, if you just learn Julia, you will suddenly unlock your potential in a way that you did not even know you could. Because, a lot of Python programmers have never learned, the low-level languages like C, or don't want to because of time. It takes a lot of time to write C programs. But Julia makes it possible. So, for example, if you look at Julia's deep learning libraries, they are not as complex as Python-based ones because they don't suffer from this two-language problem. So often many Julia deep learning libraries are just a few hundred lines of code. Many of them are actually just written by students, and a lot of them are actually written by students from India. In the Julia community, we participate in the Google Summer of Code. So we have a lot of students. In fact, half our Google Summer of Code participants in the Julia community come from Indian universities. And, someone might think that, sorry? Oh, I think I just my own echo. A lot of people might think, oh, these are people coming from like the big IITs and stuff. And the answer is actually no. I mean, people come from the big IITs, but they actually come from colleges all across the country. And, it's amazing that talent exists everywhere. And people come with such amazing, training and passion. And a lot of these libraries have been written by students without being great experts at this field, like things that were written by PhDs and professors are being sort of rolled out with Julia by students in India. So it's really sort of, raised that bar in terms of being able to do new things and contribute. So a bit of a long answer to the question, but the answer is yes, you can use all the libraries that are coming out in Python, but you can do a lot more.
Are there a lot of libraries in Julia already?
Yes. So if you look for Julia's Flux ecosystem, fluxml.ai, you will start seeing all the things that are out there. And the website is a bit out of date. So there's actually a lot more than what the website talks about. I would say that if you're interested in Julia, first go to juliaacademy.com. Okay, that's a free learning resource, juliaacademy.com. Lots of beautiful videos and tutorials. It's structured as courses. So you can teach yourself Julia and machine learning just sitting at home watching a few videos without needing anything else. And then join the Julia Slack and the Julia Discourse. So Slack is our, of course, it's the Slack like everyone else uses, and Discourse is our mailing list. And this is where you find the community, and this is where you can participate. On the Slack channel, we actually have a community in India channel, which focuses especially on building the Julia community in India. But if you're interested, this is the path to joining the Julia community and becoming a part of it. Okay. We are very good at having people sort of start out as being mere users of Julia and graduating all the way towards becoming a contributor. So, it's a treadmill. It will automatically propel you in that direction. You'll start, saying, you don't start out with Julia thinking I'm going to become an open source contributor. You just say, oh, I'm just going to use it to solve this one little problem. But then you get sucked in, and then you sort of, you wake up 2 years later and you find that you are a compiler writer at the end of the day. And this has actually happened with many people. So, it's a fantastic story and the journey in some sense.
Okay. There's this question from Lakshman. Any insights on whether there are any non-academic research labs in India working with Julia and AI?
Non-academic research labs working with Julia and AI. I know for a fact, and this is because I used to collaborate with them, that the Intel lab in Bangalore is a major place that does that. It's run by Pradeep Dubey, and so he's a distinguished Intel. I think he's an Intel fellow, and deeply focused on research. So they've done some phenomenal work out there with deep learning and AI systems that I definitely know of. I'm not too deeply plugged into sort of what the other industrial labs in India are doing personally, but I would be surprised if I would be surprised to hear that they're not doing anything with deep learning. But Intel has been a very sort of close friend and partner, and a lot of the contributions in Julia have actually come from people at that Intel lab. The one that's right there in on the outer ring road in Marathali.
We know them well. Yeah.
Yeah.
Mm-hmm. Okay.
All right, so maybe moving on a little bit. So, I have a very long presentation, but my goal is not to go through the whole thing, but just use some slides as storytelling aids, as I was saying. So please let me know.
Faster than Python and R, is it?
This is actually a logarithmic graph. So, if you look at Python, this is 100 times slower than Julia, this red dot, right? So these are all the different programs in this benchmark, and all the languages to the right are, for example, in Octave, using this recursion Fibonacci benchmark is 10,000 times slower than Julia. So this is a ratio, right? So it's a ratio in comparison with C. So if you're on this line 10 to the power 0, which is 1, you're as fast as C. So Julia is very closely clustered around 1, so it's no more than twice as slow as C. In fact, it's actually a lot better now than since I made this benchmark slide. So these are even more tight. But if you look at Python, if you look at R, they can be 100, 200 times slower than C. I mean, and this is why, right? If you're running your program on the cloud, your analytics algorithm on the cloud, you're paying for this in real money, right? I mean, if you're running 100 times slower, you're paying 100x more money. It's just as simple as that.
Oh, really?
Right?
Okay,
I mean,
that much because you're taking more time too. Okay.
yeah, I mean, you're paying by the hour, so Amazon is loving it. I mean, run it as slow as you want,
Really?
for them.
Okay.
Yeah. So yeah, but Julia is the so often you think, okay, why should I learn a new thing? I'll just instead of 1 minute, I'll run my program for 10 minutes, right? Like on my desktop. Okay, that doesn't really matter so much. But now you're running it on the cloud, and instead of running it for 1 day, you're running it for 10 days. Okay,
Right,
now
that's money.
now it's real money, right?
Okay.
And I think this especially matters to India because we Indians are very, very cost conscious, right? I mean, businesses in India run on such thin margins, right? That we produce, like I have this lovely story that a friend and mentor of mine, Bharat Goenka, who's the creator of Tally, right, told me once. So he said that, look, how does the grain merchant in India, right, the guy who's selling rice, make money? He says he buys the rice for 100 rupees and he sells the rice for 100 rupees. So how is he making the money? Any guesses? He's selling the gunny bag for 10 rupees.
He sells.
Yeah, the bag in which the rice came. So
okay. Really?
Yeah, I mean, this is how this is. I mean, it's a bit romanticized and stylized, but it's not too far from the truth. I know for a fact that my grandfather, used to do these sorts of things. When he first started his grocery store. So,
okay.
I mean, and this is throughout the country, right? I mean, we are paying such tiny amounts of money for our data, right? Like, in the US, we pay 100x more for data than we pay in India, right? And at those margins, I mean, you don't have the money to spend on fancy infrastructure and on fancy systems, right? I mean, you need the cheapest possible thing to get the job done. And, so for example, the Indian telecom networks, right, they were built on Linux. They were not built on Sun, fancy Sun hardware back in the day, 20 years ago. That's what, made Airtel bring down the prices and Vodafone bring down the prices. And that has now become our 4G networks. And we've just kept driving the prices down. Our challenge as a country is that we haven't been able to export our things and become larger, more meaningful players on a global scale. Mm-hmm. But within India, the prices at which we develop technologies, our businesses are just unbelievable. Mm-hmm. So Julia is definitely part of it, right? I mean, why would you spend more money running, on electricity and on buying compute if you could? All right, so now there are 10,000 companies using Julia. People always ask me, oh, I haven't heard about Julia. My boss doesn't let me use Julia. My cubicle mate is a diehard sworn fan of Java and, will never learn anything new. So these are just a few tiny list of companies that are using Julia, and they are the best and best in the world, right? The best research labs, the best universities, the best companies, everyone is using Julia. If not in a big way, there are small groups that are doing the most cutting edge, innovative things. It is the people who matter in the company that are using Julia, right? The people who are building the best new technologies that are using Julia.
Some examples you can give?
These are real examples. I cannot dive. I can give some examples where people have actually given us permission to speak about it. So, for example, the Federal Aviation Administration, working with MIT's Lincoln Laboratory, came up with a new algorithm for collision detection in airplanes. So, in the next few years, there is a little radar box on every airplane that gives the pilot a warning if it is within 60 seconds of a mid-air collision with another aircraft. In fact, in the 60s, there was this horrific mid-air crash of 2 passenger airlines in the US, and that led to the creation of this system. But this system now, what happens is that it was designed 30, 40 years ago. And nowadays it gives many spurious alerts because it was designed in an area of much less air traffic. So now you're parallel runways, right? So 2 planes landing very close to each other, but they're not colliding, right? So you need a new system which can deal with the challenges of modern airspace and modern air traffic. And that system actually is very computationally heavy and sophisticated and uses very deep mathematics. So the Federal Aviation Administration came out with a new guideline, right? With not a guideline, with a new specification of the system that every aircraft manufacturer has to implement. And that specification is a Julia program. So Boeing and Airbus and everyone who have to put this new box over the next few years, or every UAV, right? Every drone, not a drone like the small ones, but the UAVs that are, unpiloted, but sort of bigger and, sort of more like aircraft, like planes. All of those need to run this algorithm, and that is a Julia program, so that the Federal Aviation Administration and the world aviation regulators have implemented. I would be not surprised to see more avionics systems being developed in Julia going forward. Sorry, go ahead.
Some of these boxes already started being implemented in the planes, or?
Not. I don't think they've made their way into the planes yet, but I believe that it has. The flight tests have been completed, and the vendors are actually implementing these specifications now, because we get a lot of frantic calls from system integrators saying, "I just received this Julia program. What is this thing?" Because aerospace is a very conservative industry, right? I mean, they're not running your fastest chip on the aircraft, right? They're running a very old, radiation-hardened, specifically designed chip and compilers and systems, right? Because these are very complex things that they are very meticulously designed. So pace of innovation is slower. So for example, another one that I can talk about is Aviva, which uses Julia for, Aviva uses Julia for their risk management system. So every time, the entire Aviva, right? So Aviva India is one of the 300 companies that makes up the Aviva global company within the UK, the holding company. And Julia is used to sort of, check if, so the regulators require the insurers to hold enough capital so that, depending if too many claims come in, right, the company will be able to meet them, right? Like just like the banking regulator keeps the bank safe, the insurance regulators make sure that insurance companies, are safe and have enough capital to pay out their claims and all that stuff. All of that at Aviva is done in a Julia-based system. Let's see if there are a few others I can talk about from this list.
Yes, this question based on this slide from Pawan Kumar saying, I see AstraZeneca in the list. Any insights on whether Julia is helping humanity's fight against COVID-19?
So the answer is yes. This particular instance of AstraZeneca here is based on a research paper that they published. But that's one that I'm unfortunately not at liberty to disclose beyond saying that it is absolutely crucial part of that fight. And many companies are using it. In fact, we have a modern Julia-based software called PUMAS, Pharmaceutical Modeling and Simulation. So if you go to the Julia Computing website, you'll see this system called PUMAS, which is used for, once the drug enters a clinical trial phase, there is a huge amount of this. I actually gave this example of derivatives and rates of change about when you consume a drug, how it interacts with your body. And PUMAS is actually the tool that models it, and based on which you figure out what the dose is, how many times a day it must be given, what is it for adults, what is it for children, and that's how sort of the, that label on the drug that comes out, all of that stuff, that analysis is what PUMAS makes possible. We just launched PUMAS 1.0 about 2 weeks ago. So it has been available in beta to the pharma companies over the last year, but it combines modern AI technologies with the regulator approved methods in a package that combines the old with the new. And that is what is sort of being used by many companies in their respective, efforts.
Okay.
I might even have a slide on it. Maybe I'll come to it. Okay. Julia is being taught at all these universities, and this is just a small list. We've seen Julia downloads from over 1,500 universities already. But at MIT, at Stanford, at Cornell, at all these places, you will learn Julia if you're teaching, if you're learning there. And I believe there are a couple of IITs and at least IIIT Delhi that have taught some courses in Julia in the past, but I have unfortunately not been in touch in the recent times. But I would be surprised to hear that they've not, started doing more in Julia.
Computer science courses, these the universities here?
Often they are more in the mathematics side of things initially. So the parts of mathematics that intersect with computer science are the ones that usually, so machine learning courses, discrete math courses, things that are heavily algorithmic are the first ones to adopt Julia. So this has sort of been the interesting thing about Julia, that and this is why computer scientists are often not familiar with it, is because it usually comes from the math and engineering and science people. Those are the backgrounds of people who usually adopt Julia first compared to because at the end of the day, computer scientists are good at programming. So, they don't mind Java, Julia, Python, like they're more proficient in these tools compared to a scientist, an engineer, a mathematician who just simply, finds these tools difficult to work with. So that's where it usually starts out.
In terms of ease of writing, how is it? People say there are some languages like Python and all which are easy to write. The syntax is simpler, whatever.
Julia is even easier. As Python. Yeah, I would say if you're a Python programmer, within a day you'll be writing Julia. And well, it'll take you some time to master it, because mastering anything new is, it takes time and patience and focus and learning. But Julia actually has what we call a graded set of abstractions. So you don't have to master the most difficult things about Julia on day one. You can start out with a few basics, and you will actually become already very proficient with those few basics, and then you can graduate to the next step and to the next step and to the next step. So that's what sort of makes learning Julia very, very easy. The Nature article, the Nature magazine, the topmost scientific publication, actually wrote an article, "Come for the syntax," which is the ease of use like Python, but stay for the speed. Lots of books available on Julia. These are just a few that I have on the slide. The Julia website will give you a lot of these things. A lot of packages, like a lot of Python people probably are thinking that Python has all these amazing libraries. Maybe it has 10,000 libraries and Julia may only have 3,000. I don't know. Python probably has 100,000, but Julia only has 4,000. I always ask these people, how many of those 100,000 do you actually use? Probably the answer is no more than 50, right? Those already exist in Julia, and many of them are actually really, really high quality. And some of these, like Julia, like for operations research or like the robotics ones, are not even available in, or the differential equations, for example, are not even available in Python. None of them are available in C++ and Java for sure. So I think maybe this is a good time for me to stop, right? Because now I get into very deeply technical parts of this presentation. So I think this would be a good time to sort of take a few more questions. Yeah.
Yeah, we have a question from Hamza Abid. How long will it take for me to master Julia programming language? Any special tips from the co-creator?
Like I said, you get started within a day, and it doesn't take too long to master it. Start with juliaacademy.com. That has all the sort of amazing videos to get you going. And it's completely free, by the way. Yeah.
Right.
A Python person from shifting to Julia, when you're saying it's so much better, is just the mental laziness or something more than that?
No, it's the same effort, but Julia is a better technology in terms of producing higher performance code, right? So, like I remember I showed you that factor of 10 or 100, right? On the performance chart. With the same effort that you would have written that program in Python and in Julia, you're just going to get that much more performance. So that is what the key is.
So what makes a Python guy stick to Python and not move to Julia right now?
It's just that it's new, right? And it's just, so Python has been around for almost 25 years. Julia has been around for 10, right? And these things have they have exponential growths, right? Because 10 years is when the language starts getting adopted. So Julia has actually started its adoption. So we released version 1.0 of Julia, which is the first stable version of the language, only in 2018. So it's barely been 2 years now that we've actually been out. And then it is also a social construct, right? I have to use the language that everyone around me uses, that I can find help on easily. that my boss, says I should use, or my university teaches. So these are very slow processes, and these are social processes that take time to build upon them. And they are, like I said, exponential, right? So the first time one person teaches Julia to two people, those two will teach it to four, the four will teach it to eight. So the initial growth is very slow, but eventually it compounds in a huge way. I mean, it will explode, right? Python went through that journey 10 years ago, right? I bet you that all these people who are talking about Python were not even using it. 5 years ago, no one had even heard of Python. And I would also like to point out that Python, this is not about migrating to a new thing. It's not like you leave Python and move to Julia, right? As a programmer, you have a toolbox, right, of multiple tools that you use, and Julia is a new tool that you need to add to it. It's not like this toolbox only has a fixed amount of space. So to add one new thing, you have to take out one thing out there, right? You don't delete Python from your mind. So what Julia will do is it will enhance you as a programmer. It will teach you new things that you might have not known about before. It will teach you new ways of thinking. Julia is more of a functional language, unlike Python, which is more of an object-oriented language. Certain people think functional is strictly better than object-oriented, but the answer is that you should just learn more things and master more things and become a better programmer and use what is right, for the job that you're getting done. And there'll be certain things where Python is still better than Julia, and there'll be certain things where Julia is much better than Python. So I would sort of take it as a union. I would take it as an inclusive thing rather than replacing one with another, which is often what people think about this as.
A related question. I'm working in data. This is from Parth. I'm working in data analytics using R and Python as part of my professional commitments. Can learning Julia improve my job prospects in the Indian market?
I know for a fact that all the major Indian service providers are reaching out to us to learn more about Julia. Right? I've spoken with all the big, the Infosys, TCS, Tech Mahindra, Wipro. I've spoken about Julia. I've given talks at all these companies. I know that many of these people are internally using Julia Cognizant. To the extent, what level are they hiring and how much of their business is in Julia, I'm not privy to that information. And I think looking on the recruitment sites is probably a better answer to that. But, I personally believe in learning things, out of curiosity and about sort of always being at the cutting edge. Not necessarily only by the time you're doing something because big companies are hiring, you're probably already late. That's how I see it. So if you're looking to maintain a competitive advantage, you need to be ahead and trying out new technologies. I mean, what is an employer at the end of the day looking for, right? They're not looking for someone, okay, I got this guy, now I will have to teach him Julia, then I will teach him this and that, right? I mean, they actually want someone who comes with a drive, right? Someone who comes with initiative, right? And someone who's ambitious, who wants to learn and grow and build the business rather than sort of just come and be a part of it. So I mean, and different people have different goals in life and objectives, but I personally feel that, one should always try to stay ahead of the curve, learn new things. And the new thing may not be Julia. I mean, you may learn new algorithms, you may learn, I mean, with online courses and everything, I mean, sitting in your, in your drawing room, you can, the world is at your fingertips now. So I would say that if I'm an employer right now and I see someone who has not taken that initiative, I have 100 other options where people have taken that initiative, and I think you'd be left behind if you don't do that in today's world.
Got it. Shilpa?
Yeah, we have an interesting question from Chandan Jha. Any reason for the name, why you named the language as Julia? Any backstory or anecdotes to share with us?
Who else was involved apart from you?
Oh yeah, actually, I didn't get a chance to talk about the origin story at all somehow in this whole conversation. So there were 4 of us who started the Julia language. So it was Jeff Bezanson, Stefan Karpinski, Professor Alan Edelman, who is at MIT, and myself. I sort of am the person who kind of connected all of them together. So Stefan and I were We went to graduate school in the same PhD program at UC Santa Barbara. And then Alan and Jeff and I used to work at a small company called Interactive Supercomputing back in those days. The company wound up in the last financial crisis and was acquired by Microsoft. Jeff and Alan and I did not join the company. In fact, we are the only three who did not join Microsoft. And we started Julia, and it's the best decision that I ever made. It was a very safe career path to have been on, and I probably would have made more money if I had stuck with it, I'm guessing. But I would not have got to do Aadhaar. In fact, it's because I did not take that job. I ended up back in India. I ran into Nandan in a random conference. Never even heard of who Nandan was back then, by the way. I was like, okay, who's this guy? Maybe some minister types who's building some IT. Okay, I don't want anything to do with it. But 10 minutes of talking to him, and I was like, no, I'm going to do this. So that's how Aadhaar got started. And that's exactly the time when I was, connecting up these folks over email, and all of us started talking about Julia. So I say this in my book, in Rebooting India, that I met Nandan. The next day, found myself talking to the post office, the chair, I think it was chairwoman at that time, chairwoman of the post office, and the first line of Julia written same exact week, actually. And I actually recollect those incidences quite vividly, the contrast, as you can imagine, that deep in the bowels of Indian bureaucracy versus cutting edge, high tech, new thing. Yeah.
The name Julia?
Oh, the name Julia does not have a real backstory, so we don't have an official story. But you should look on the internet for all the reasons other people have. They're far more entertaining.
There's a question I have from Lakshman Natraj. For the performance graphs you showed where Julia was better than Python, are these graphs on GPU or CPU? Does Julia have good performance on CPUs?
Yes, those are CPU graphs, actually. There is a similar graph on GPUs. So Python cannot even run on GPU, so you can't even make the chart, because it would just be Julia and then nothing. But let me actually, let's find it, right? We are on, the benefit of the internet is that I can actually find this stuff right away. So can you see my screen?
Yeah.
Okay, so so there is this Julia on the GPU website. So by the way, Julia is one of the very few languages that can run on GPUs. Usually you have to write only in C++. So let's look at NVIDIA GPUs. Oh, there you go, performance. So this is the performance between Julia and C. Okay, there is no Python, because Python cannot run on GPUs. It has to call programs written in C for GPUs. But Julia has a native compiler that runs on GPUs. You can download it from this juliagpu.org website. And this shows that the Julia performance in some cases is slightly slower than C, like by 3% or something, but it can be about 22% faster on certain kinds of applications. I mean, and this is crazy, right? Because C is considered the speed of light, that it cannot be exceeded. That's how programmers think. So usually their mind is blown when they see that Julia on GPUs is actually, in some cases, faster than C. And the C thing has been built by hundreds of millions of dollars invested by NVIDIA. And Julia is being built by a couple of graduate students who obviously we have gone and hired at Julia Computing because they're so amazing. So one of the researchers who built this is at MIT, Valentin Shiravi. But actually the person who's leading the charge is now at Julia Computing, Tim Bassard, who's based out of Belgium. So Julia is this unique worldwide community. And anyways, actually, I would like to point out that Julia is one of the very few open source projects where one of the original creators, that is me, that I did all my Julia work out of India. It's only in the recent time that I moved to the US, because now we are building a business at Julia Computing. And in order to build a business, I had to be sort of where the customers would be first. But all my work on Julia from day one was done from my time in India. And as a result, we built a very large community of contributors and interest in India. And it's one of the few projects where India has an outsized contribution.
Really?
Yes.
What kind of numbers are we talking?
Oh, the numbers are hard to say, but if you look at like large parts of the Julia programming stack, right? Like a lot of the distributed computing capabilities of Julia, for example, have been built out of Indian contributors. a lot of our graphics packages, some of our data processing packages, a lot of our AI stack continues to be built by Google Summer of Code students from India. So I would say that yeah, I mean it's hard to sort of count numbers, but if you look at visitors to the Julia website, like India ranks as the 3rd or 4th largest visitors after like US, China. It's always a tie between Germany and India. Of course, given India's size of programmer base, it should be number 1. So we are not punching, we are punching below our weight at the moment. But I really hope that people watching, watching this video and the kinds of activities you guys are doing can really reach more people and get this message out there. And often just seeing that someone could do this from India is a big unlock for many people, right? Because maybe a lot of times you always think that maybe I just cannot do something like this, right? Or what does it take? And just seeing the stories of people who did this is sometimes motivating enough for you to take that first step.
Absolutely.
And so this is why I've always, every time I have a speaking engagement or an invitation from India, when I was in India, I would physically go there and do that and engage with people. And online, I always, sort of try to do as many of these as I can. And I really wish there was an easier way to reach out to people, but one step at a time.
Yeah. Shilpa?
Yeah, we have a question from Arvind. Python has wrappers which call C functions. What does Julia do under the hood?
Actually, it's much better than, you don't need a wrapper to call C. Actually, why don't I, this is a great idea for me to do a little demo. How about that? We'll actually run some Julia code out here. So I downloaded Julia and I just installed it. So this is the command line Julia. This is not how you would usually program in Julia. Usually you would program using an IDE. Okay, there we go. So this is how I like to sort of interact with Julia. So maybe this is big enough now. It's the latest version of Julia 1.5. And, we have a thing called C call. So to call C programs, and you can look at the help. That's what it looks like. So if you're a C programmer, you know that there is a C program. I'm just going to call a very simple C function in like, 5 seconds out here, right? So C call, there's a function called clock that returns the time from the, I think it's the time from 1978 in seconds, something like that is what it does. That was the day Unix was first created, I think. So the clock function gives you the time in seconds, and then it gives you your answer in seconds. So I will say that's an int 32-bit integer, and then it does not take any inputs. So that is an empty tuple, and there you go. So I did not use a C compiler. I do not need a C compiler to call a C function. I don't need anything. It is literally built into Julia, and it is very high performance. It is as fast as calling this C function from Julia as it is to call it from C. And just to show you that is not a trick, I'm calling it again, and you see number of seconds has gone up when I call it again, and so on and so forth. So it's literally that easy to call C from Julia. It's not possible.
What are these numbers?
So this is the number of seconds that has elapsed since 1978.
Oh, okay.
Right. So you can ask the operating system what it actually is. I might be wrong about the exact year, 1978, but yeah, amount of processing time used. Yeah. No, this is a different. Sorry, never mind. I keep forgetting which operating systems I'm on and what they do. Why did I quit Julia here? Okay, let's go back into it. Yeah, but the reason is that when Unix was first created, they had a function that said that, I need something to compare as time passes, right? So, and then when you have the concept of time, time is not an absolute concept, right? It's always relative, right? So when you say that time has passed, you have to have a reference point from where it was passed, right? Otherwise, what does it mean? Is it from the creation of time, Big Bang? Is it the universe? What is it, right? And so obviously it made sense that if you're counting time in Unix, it was when Unix was created first. And that's why C and Unix were created hand in hand. And so that's why that is from the time when Unix was created. Problem is this time counter is going to run out in 2032 or something like that, in about 10 to 12 years from now. And then it is going to wrap around and become 0. So we are going to have another Y2K coming around.
Really?
Yes.
Oh, okay.
But that is because this time is kept in a 32-bit. If you saw that, I called it as a 32-bit integer, right? So the world is in the process of migrating this from 32-bit to 64-bit, which then will last beyond the end of humanity. Yeah, so some deep thoughts there, but but it's a mini Y2K, so you can read about this online if you search it.
Okay.
Viral, we have another question. Julia combines the best features of Ruby, MATLAB, Python, R, C, and others. But if you can talk about the speed of code and the high performance code, where do you think Julia still has to play catch up?
In terms of high performance, I would say that in fact others are playing catch up to us, because we don't have, Julia is the only one that has these GPU capabilities, right? It is the only one that can easily run on TPUs. It's often the catch up, I would say, to play is at what is called as exascale computing, or running on millions of millions of computers at the same time, right? Like the world's largest supercomputer. So while Julia already runs on some of the world's largest supercomputers, it's not common that the typical open source contributor has access to something like this, right? It's a very expensive resource, and hence it requires a lot of effort in programming those kinds of systems. So the systems that are one of a kind, that have very few users, right, probably few dozens of users, and are very specialized, I would say that we still have work to do at that absolute crazy scale. But I would say that otherwise, we are literally at the forefront of what is possible today in high performance computing.
Then there's a question from Chandan. That's one part of it I also wanted to ask you. First part is Julia a good language? I think you kind of mentioned it earlier. Is Julia a good language at the deployment stage? And the other question is, will Julia replace Python in the future?
So the answer to the first one is yes. And in fact, this brings me a chance to talk about JuliaCon. So if you go to juliacon.org, so this is, just like we're doing this online, we had to do the entire JuliaCon online. And while typically only 300 people come to JuliaCon every year, because physically you have to travel, and it was supposed to be in Portugal this year, actually. But that did not happen. And as a result, it ended up being online. And instead of 300 visitors to the conference, we had 26,000 on the YouTube channel. So we have now sort of decided that we have to sort of make this online part of the conference a lot more serious going forward, because there is such a huge interest. A lot of interest, viewers from India, actually. So there was a whole one-day session at the conference. If you look at this videos link, you can go there and find it, which talks about how to deploy Julia in production. So let's see. Can I even find it right away? Is it HTTP? Okay, there are 164 talks here, so I won't be able to find the title very well. But it was one of the, there was a one-day workshop, actually. And let's see, if you go to live schedule, agenda here. Yeah, okay, so there it is. This one, building microservices and applications in Julia. Okay, so there is a whole one-day session on this that you can learn. The second is it going to replace Python? No, nothing ever gets replaced. We have not even replaced COBOL yet. So the answer is obviously no. The answer, like I said, is always you have to learn new things, and new things will be used in building new software, but the old things will always be continued and will be there for maintenance.
It's primarily in the analytics area. So you're not trying to extend it to other areas.
Julia is capable of doing everything, but I like to think of where is your best advantage, right? At the end of the day. So while Julia maybe is, let's say 2 to 3 times better at Python than running a web service. Actually, it's much more, but I'm just trying to take a simpler example here. But well, let's say compared to Java, right? Like Java is a great way to build enterprise systems, and Julia has a lot to catch up in the libraries to do that. So Julia, even with its language benefits, maybe at best as good as Java, or maybe 2 or 3 times better in certain cases. But when you're doing analytics or scientific things or deep learning or AI, it will be 10 to 100x better, right? So when you have that level of advantage, that's the one you really push on, and that's the people who first come to you, right? And then those are the people that keep pushing it forward. So Julia is a completely general purpose language. So for example, R and Python are the two ones, right? But people don't build websites in R, right? They don't deploy microservices and applications in R. They do that in Python. So Python is a lot more general purpose than R is. It's not that R is not capable of doing it. It's just not suitable the way it has evolved and stuff. Julia can actually do both of those well. So people are doing it, but I'm not going to go and build my enterprise database application that is doing my record keeping in my company, right, from Oracle and Java to Julia. It just doesn't make sense to do that. So you never replace these things. All of these things coexist, and Julia will have a role to play in that system, right? Wherever you're extracting data out of your database and you want to do some analytics, some deep learning, some new insights, some new algorithms, it will plug in. And that's the point of this talk, of how you can build these systems that can integrate well.
Okay. Great. Oh, I thought questions were over, but here's one more. Shilpa, you also have?
Yeah, one question, Sujit. Maybe you want to ask and then I'll follow it.
Okay. This is from Renal. How secure is Julia when compared to other languages?
It's no more or no less secure than any other language can be. It is actually, let me back that up with something. So Julia will, unlike say, C's memory model where, so Julia will do bounce checking and such things. So it is safer in that way. It is garbage collected language. So I would say that, if you think of like the modern things that a language like Java does, which is memory management, garbage collection, safe allocations, that kind of stuff, all that Julia already does all that stuff. So, yeah.
Shilpa, maybe after that you can wind it up. I think it's.
Yeah. So if you can talk about some of the major developments that came together to develop Julia 1.5, right? So what are some of the highlights?
Yeah, so Julia 1.5 has a lot of amazing features. It's actually, so we wrote a blog post about it, and so this is the Julia website. And then if you go to the blog, there is Julia 1.5. Oh, it's not the latest blog post anymore. The latest one is JuliaCon 2020 blog wrap up. Okay. So I would just highly encourage you to read this thing. The first two things here are the big major improvements. I mean, these are just like, the ability to do struct layout and allocation optimizations, and then multi-threading, which is the ability to use all the cores in your CPU, the multi-core systems. We made tremendous improvements to those two things. And that is, I think, the biggest draw for upgrading Julia 1.5. We also had our package ecosystem become we replaced the way packages are served in Julia. So how you install the add-on libraries, so that infrastructure was completely overhauled. That makes it very easy to install Julia now and Julia packages compared to before. It was already pretty easy, but it made it even better. So we have deployed a whole a distribution network for serving Julia packages with servers around the world, so that you can get it, you can get fast download speeds and all that good stuff.
Sure. Thank you so much, Viral.
Bombay, you said, huh?
Sorry?
You grew up in Bombay through all your.
Yes, yeah, born and brought up in Bombay until I went for my PhD.
Great.
Great. Thank you so much, Viral. Thank you for sharing your journey on how you co-created Julia out of India. I would love to hear how you're planning to grow the community. Thank you so much for taking the time out and speaking to us.
Thank you.
That's really nice. I think we had a lot of questions also. Great.
Yeah, any more questions pouring in, but
yeah. Well, the answers can be found online as always, and if not, ask on Stack Overflow, ask on the Julia discourse, and people will be there to answer.
Sure. Thanks much for your time, Viral.
Okay, thank you. Bye.
Bye.
For having me.